Okay, we're going to be doing some graphing on a number line. First thing, when you do make a number line, it does go on forever. It's a line, so make sure you put the arrows on the end of it. We need to go from -4 to 3. We can't just put these numbers on, so we're going to need 0, 1, 2, 3, 4. Look like a 3. And then -1, -2, -3, -4. I usually do go one beyond what we're graphing. I guess you don't have to do that, but so make sure you make your number line correctly or everything else will be wrong. Now here we're graphing individual points, so you can put colored in dots right on the number line. So we need a colored in dot on -4, but make sure it's big enough that we'll see it, on -1, on 0, on 2, and on 3. So you do not make a number line just with the numbers you need, you just make a regular old number line. So in this one, again, we need to make sure we make our number line first. We need to go from 0 to -4. 1, 2, 3, 4, and 1 beyond. So 5, 4, 3, 2, 1, and they're all negative. And what do those 3 dots mean? It means the pattern continues. So we first need to establish the pattern. So we need a dot on 0, maybe, -1, -2, -3, -4. Since I did add -5, I need to make sure I have a dot on that. And to show that it continues, we're going to darken in and color in the arrow like this. So that shows that the pattern we established is continues. But if I would have put like a -6 on here, I would have to put a dot on it because it does mean it keeps on going like that. Next, we're going to talk about different types of numbers that we have. And the first one we're going to talk about is natural numbers. Also known as counting numbers. So they are basically just what that says. Where do we start counting? 1, 2, 3, etc. So remember the 3 dots mean the pattern continues. After natural numbers, we have what are called whole numbers. There's not a lot of difference between natural numbers and whole numbers. Whole numbers are the numbers 0, 1, 2, 3, etc. So that includes 0 where it didn't before. Then we have integers. And integers are whole numbers and their opposites. So whole numbers, 0, 1, 2, 3, etc. But also -1, -2, -3, etc. And then we're going to talk about rational numbers. We will talk later on about another type of number, but right now it's any number that can be written as A over B. So any number that can be written as a fraction. We do have to stipulate that B cannot be equal to 0. So hopefully remember why, because we cannot divide by 0. So those are different kinds of numbers that we can have. And we're going to be working with those different kind of numbers here. Absolute value is the distance from 0. So if something's to the left of 0 2 places, its absolute value is 2. If it's to the right of 0 2 places, its absolute value is still 2. So absolute value will not be a positive or negative. So what is the absolute value of -5? 5. What's the absolute value of 8? 8. What's the absolute value of -5/8? 5/8. Those should be pretty simple for us if we just understand it's the distance from 0. And then we can use that to evaluate, and remember what we've done with negative numbers. So I'm going to just replace the y and z with the numbers I'm given and then do a math problem. So it's 18 minus absolute value. I'm going to replace the y with the -3, and then minus, and z is -8. Absolute value symbols are like grouping symbols in that we need to do what's inside first. So I'm going to add the opposite rule. -3 plus 8, signs are different, so I subtract, keep the sign the bigger number, I get 5. The absolute value of 5 is 5. So my problem is now 18 minus 5, which would be 13. Here the absolute value, or sorry, x is equal to 2 minus 6, and then minus 7. So 2 minus 6, remember, becomes plus negative, which would be negative 4. The absolute value of negative 4 is 4. So our problem is 4 minus 7, so plus negative would be negative 3. And that would be what we would have there for that one.